Rectangle A has length 6 and area 36. Rectangle B has length 12 and area 36. Rectangle C has length 9 and area 36. The rectangle with the smallest width has a width of x. What is the value of x? So rectangle A, B, and C. So the area is always length times width, right? So if the area is 36 and the length is 6, then the width here would be 6. In a very similar way, and for B, the length is 12, so that width would be 3. And for C, the length is 9, so that width would be 4, I believe. So the widths are 6, 3, and 4, and they're saying the one with the smallest is x, so the smallest is that, so therefore x is 3. What is the sum of all the prime numbers that are greater than 10 and less than 20? All right, let's list them. Let's start with 10 and let's end at 20. So the prime numbers between 10 and 20 are 11, 13, 17, and 19. So they want you to sum. They want you to add them all up. So when you add them all up, it's 60. Just those four. Starting on the 22nd floor of their apartment building, Taya goes up the stairs and Jenna goes up by elevator. Beginning when Taya starts going up, Jenna waits for 2 minutes for the elevator. Taya goes up from each floor to the next floor in 15 seconds. The elevator goes up from each floor to the next floor in 3 seconds. Taya and Jenna arrive on the nth floor at exactly the same time. What is the value of n? Okay, so there's this 22nd floor and both of them are going up, but one's, I believe, taking the stairs and one is taking the elevator. Okay, so Jenna, she waits 2 minutes and then she goes up 3 seconds at a time for each floor. So if the floors are represented by k, it's 3k, where k is in seconds, so I've got to convert that 2 minutes to 120 seconds. And then Taya is 15 seconds, right? Yeah, 15. And she's walking up the stairs, so hers would be 15k. So for Jenna, it would be 120 plus 3k, and for Taya, it would be just 15k. And these are going to be equal, they're saying. So that means 120 is equal to 12k, so therefore k is equal to 10. So they both went up 10 floors. And they're saying they arrive at the nth floor. So if they started at the 22nd floor and they went up 10 floors, then that means they ended up at the 32nd floor. So I think that is it for this question. In the diagram, ABCD is a rectangle. P is on BC, Q is on CD, R is inside ABCD. PRQ is 30, RQD is W, and the rest of the angles are X, Y, and Z. What is the value of W plus X plus Y plus Z? Okay, so this is what you call angle chasing. So here we go. This angle in here, I'll call that, well, whatever, alpha, let's say, and this one, I'll call it beta. So let's see here. If you go from here to here, that W plus alpha plus X is 180, right? And then if you go all the way from there to there, that's also 180. So that would be Z plus B beta plus Y. And then inside the triangle, 30 plus alpha plus beta is 180, right? Sum of the angles of a triangle, inside a triangle. So that means alpha plus beta is 150. And then these two guys, if we add them, that would be X plus, well, W plus X plus Y plus Z plus alpha plus beta is 360. And then we can substitute that for that. So then it would be W plus X plus Y plus Z. And therefore W plus X plus Y plus Z would be 210. A list of numbers is created using the following rules. The first number is 3, second number is 4. Each number after the second is the result of adding 1 to the previous number and then dividing by the number before that. In other words, for any 3 consecutive numbers in the list ABC, C would be equal to B plus 1 over A. The rule tells us that the third number would be 4 plus 1 over 3, which is 5 over 3. What is the smallest positive integer n for which the sum of the first n numbers in the list is equal to an odd integer that is greater than 2021? You're going to need a lot of space for this one, I think. So let's start off. n1 is 3, n2 is 4, and n3, they gave us that, but it's really this 4 plus 1 over 3, which is 5 over 3. And they just keep continuing. n4 would be same thing, 5 over 3 plus 1 over 4, doing the same thing that they have told me. And if we do that math, that would be 2 over 3. And then n5 would be 2 over 3 plus 1 all over 5 over 3, and I believe that's 1. n6 would be 1 plus 1 over 1 plus 1 over 2 over 3. And that would be 2 over 2 over 3. So 2 over 1 over 3 over 2. So that's equal to 3. Okay, and 7 would be 3 plus 1 over 1, which is 4. And 8 would be 4. Oh, I see a recurring pattern here, 5 over 3. Okay, I got it. I mean, I don't have the answer to the question, but I have sort of a understanding. Okay. So as you can see, 3, 4, 5 over 3, 2, 3, 1. 3, 4, 5 over 3, 2 over 3, 1. So it repeats itself. Okay, I got it. So now, I mean, obviously I have to tackle the actual question, but one thing I definitely need is the sum, because they're asking about the sum of the first set numbers. So S1 would just be 3, right? S2 is a cumulative sum of 7, 3 plus 4. S3 would be 10, well, sorry, hold on, let me see if I did this right. 7 plus 5 over 3, right? And then S4 would be 7 plus 7 over 3. And then S5 would be 8 plus 7 over 3. 8 plus 7 over 3. Yeah, I don't see any kind of pattern there. But let's just keep going here. S6 would be 11 plus 7 over 3. S7 would be 15 plus 7 over 3. S8 would be 15 plus 12 over 3, so 19 now. It's the first time we get a number, actually. Well, not the first time. There was numbers up here, but there's been a lot of fractions. S9 is 19 plus 2 over 3. And then S10 would be 20 plus 2 over 3. Okay, but the thing is, since this repeats itself, every time the sum, when we get to every group of 5 will add up to this, right? Since it's the same numbers. So 8 plus 7 over 3 is what? 8 plus 7 over 3. Let me just think about that in terms of decimal. It's a 10.3 repeat, right? Yeah. So every group of 5 would just be 10.3 repeat, a multiple of that. So this guy here is 2 times that. So, which is 20.6 repeat. And that is indeed the case. Okay, I got it. Okay, so that means since S5 is 1 times 10.3 repeat, S10 would be 2 times 10.3 repeat. And then S15 would be 3 times 10.3 repeat, and so on. You guys get the idea. S20 would be 4 times 10.3. So what do they want? They want all the way up to 2021. Okay, so so this is like 31. So we got a long way to go, and I don't want to write it out manually because that would take forever. So let me see what I can do. Let me get a ballpark estimate. Let me see what 2021 divided by 10.3 repeat. And you are allowed to use calculators on this one. So if you put that in your calculator, I think that's 195 or something like that. Yeah, like a little bit more than 195 point something. So that means like if I do 195 times 10.3 repeat, that is going to be a sum. And that, first of all, what is that? I think it's 2015. And the sum would be, well, these are just multiples of 5. So when it was 4, it was 4 times 5. It was 3. It was 3 times 5. So this number here would be 195 times... wait, hold on. Let me think about this. Yeah, it would be 195 times 5, which is 975. Okay, so we've come very close to that 2021, but we want to go greater than that. So since I got to go greater than that, I've got to now do this thing manually. Yeah, because if I just extrapolate, I might miss it. I might go too far ahead. So let's do it manually for like 976, 977, which shouldn't take too long. So here is what happens when you do it manually. And all you're really doing is the same thing that we have already been doing. We're just doing it one at a time. So S975 was 2015. And the terms are always 3, 4, 5 over 3, 2 over 3, 1, right? Just like how before they just keep repeating. And then you just keep adding them to get the sum. So they want the odd, they only want odd integers. So even though those are integers, those are not odd. And then that is an integer, but that's not odd. This is the first time that you get to an integer that is odd. And that happens for S989. Yeah. S989. So that is what they're looking for. That is the value of n that they're looking for, 989. Dragomir has 6 pairs of socks in a drawer. Each pair of socks is different from every other pair in the drawer. He randomly removes 4 individual socks from the drawer, one at a time. What is the probability that there exactly is one matching pair of socks among these 4 socks? So probability questions, almost always they're a fraction. This is the total, and this is our specific condition. Okay, so the total, let's do that first. So there's 6 pairs. Okay, so let's put those 6 pairs there. And I'll just call this A, B, C, D, E, and F. So we have, this is sock A1, sock A2, sock B1, sock B2, and so on, right? Because there's 6 pairs, so that means there's 12 socks. Okay. All right, so out of the total is from the 12 socks, we want to choose 4 because he's gonna eventually choose 4. And 12 choose 4 is 495. And you guys know how to do choose notation, right? 12 factorial, 8 factorial, 4 factorial, and that's going to be 495. Okay, so now we just have to figure out our specific condition. Now that's obviously a little bit more challenging, so let's see. The specific condition is that we want exactly one matching pair of socks. So one matching pair. Now, when we select 4 socks, or when he selects 4 socks, there's only 3 possibilities. That you can have one matching pair, you can have 2 matching pairs, or you can have 0 matching pairs. 0. So let's figure this out. And then this one would be the total minus these 2. Yeah. That might be easy. Okay, so 2 matching pairs. 2 matching pairs. Let me just do it down here. If you have 2 matching pairs, so for example, let me just give an example. Like if you had A1, A2, and then you selected B1, B2. That's 2 matching pairs, correct? Now, how do you get that? 2 matching pairs. So from the 6 matching pairs, you choose 2. Yeah, from the 6 colors. 1, 2, 3, 4, 5, 6. From the 6 colors, choose 2 colors. And then from each, So for A, it has 2 socks. So from those 2 socks, choose those 2 for the A. And then for the B, I mean, whatever color it is, doesn't necessarily have to be A. But for the first color, I shouldn't have put A. Just put first color. First color. You from those 2 socks, choose both of them. And from the second color, again, from the 2 socks of that color, choose both of them. So this will be the number, 6 to choose 2 is what? 6 times 5 divided by 2, so 15. Yeah. So 15 is this guy right here. So 15. So 15 is going to go here. Now we do 0 matching pairs. Okay, 0 matching pairs. How do I do that? 0 matching pairs. 0 matching. So an example would be, let's say if I had A1, B1, C1, and D1. If those were my 4 socks, then none of them match. There's no matching pair there. That's just an example. Now how do I get that? Okay, from the 6 colors, choose 4 colors. Yeah. And 6 choose 4 is 15. And then if you have chosen 4 colors, each color has 2 socks. So for example, if the first color was A, you've got 2 choices. If the second color was B, you got 2 choices. If the third color was C, you got 2 choices. And if the fourth color was D, you have 2 choices. So that's how many ways of choosing, right? Because you could have choose A1 or B or A2. Similarly, B1 or B2, C1 or C2, D1 or D2. That's why you have 2 choices. And then you multiply them all, and that's 16. And then the absolute total would, you have to multiply those two. 15 ways of choosing 4 colors from the 6 colors, and then 16 possible combinations. And that would be 15 times 16 is what, 240? Yeah, 240. So that 240 is this guy, and therefore this is 240. So 495 minus 15 is 480 minus 240 is 240. So that 240 is what goes up here. And I think that's it. And then, of course, in lowest terms, that's going to be 16 over 33.